Hi, my name is Simon.
I'm Songha.
Today we would like to introduce to you a machine learning project that we've been working on for the past few weeks. It's called Instaboost. Instaboost is a service that allows users to predict exactly how popular their photos can get based on machine learning techniques. The reason we created this was because we wanted to help people use Instagram by predicting how many likes a photo can get, or by analyzing which photos can get more likes. Our motivation? We realized that we spend way too much time on Instagram trying to figure out which posts will be popular and how many number of likes and comments they will get. So, in our project, we used two predictive models. The first one being predicting the number of likes of a photo given the specific concept, such as food photos. The second predictive model is predicting the number of likes of a photo given user information of the past, for example, previous posts and number of followers. For each of these models, we used two algorithms, k-means clustering and random forest. We used sklearn libraries implementations, and we will explain what these algorithms are in a brief moment. So for each of our models, concept-specific and user info, we use two separate workflows from data gathering and feature selection to execution of regression.
So let me explain about how we process the data. For data gathering, we created an Instagram crawler that gathered information of each post, such as number of likes, number of comments, and photo, and of users, such as number of followers and previous posts. For k-means clustering, we collected 12,000 posts with food-related hashtags like
#foodporn,
more than 24 hours old. For random forest, we collected 10 most recent posts from 1,500 arbitrary users. We used breadth-first search starting from Selena Gomez, as Selena has the most followers. As features for k-means, we used RGB data and follower counts. For random forest features, we used by concepts, which are pairs of adjectives and nouns that describe the content of a photo, such as sexy legs, and follower counts and average likes of the user's previous post. To pre-process the data, as the photo dimensions varied, we resized all the photos to 50-50 and extracted RGB data and saved them as array. Then we got the 2089 by concept using Deep Centibank library for the random forest algorithm and reduced the by concept features to 576 principal components.
Now, I will talk about the algorithm that our first predictive model, the concept-specific model, uses. It's called k-means clustering algorithm. And how it works is, first we randomly initiate k center points. In the diagram on the right, that are the red and blue x's. And for each data point, the circular points, we assign them the label of the center point that is closest to the data point. And then for each blue and red group, we calculate the new mean of all the data points in the group. And this becomes the new center point. And then with this new group, we repeat what we just did. For all the data, find the closest center point, and then group them into one, and then find a new center point, and so on. And as we continue what we just did, we can see that the center points start migrating to somewhere around here. And in the end, we will get k clusters, or in our case, 2 clusters that minimize the sum of squares. In other words, this is the point where the sum of all distances from data points to the center points are minimum. So in our project, we perform k-means clustering from the sklearn library on the RGB data with 12 clusters. The images on the right signify the clusters. We can see that the least popular cluster is the badly lit photos, and the most popular cluster are the photos that are post-processed and put into a white frame. And now with each of these clusters, we perform regression on the number of followers and number of likes. And we found that exponential regression yielded the best results and minimum error. Now, if we want to predict how much likes a photo can get, then we find out which cluster that photo falls into, and then we run it through the regression model to get number of likes.
Next, let's see our second model, user info, using the random forest. Random forest is a large collection of decorrelated decision trees. The decision trees are based on random selection of data and random selection of variables. In the forest, all trees are trained independently, so the error happened in the previous tree does not affect the others. Let's see how this algorithm works. First, we draw a bootstrap sample from the training data. Then, in order to grow decision trees, we repeat these 3 steps. First, randomly select m features where m is less than the total number of features. As each tree has different features, it can learn different things. Then, just as a decision tree is implemented, pick the most significant variable and calculate the best split point among m features for the node. Then, split the node into 2 daughter nodes. We can grow a single tree to the bootstrapped data by recursively repeating these 3 steps for each terminal node of the tree until all the n number of nodes has been reached. Then we build a forest by repeating these steps. Each tree gives a result, and we say the tree votes for the result. The forest chooses the result having the most votes over all the trees in the forest, and that will be the final result. For our model, we set only one parameter, the number of estimators, as 150. As a result, we got 0.93 of R-squared score, which is very close to 1. In the graph, the x-axis is true label and y is the predicted values. We can see the points are converging pretty well in a linear line. Then let's have a look at sample predicted results of 2 users. Here we have the predicted and actual like counts of each user's 10 recent posts. As you can see, for most of the posts, especially those on user 2, predicted values do not match with the actual values, but some are pretty accurate, like the first post of the user 1. Also, the predicted values tell us which photo will be more or less popular within the same user. Here, the red is the least number of likes the user got, and the green is the greatest. Predicted and actual red and green are matching, which means if a user are hesitating which photo to post, he or she can input those photos and the user information to this model to predict which photo would be more popular. However, there is also a limitation in our model. For users whose average likes of the previous post is less than 150, the model can estimate the approximate like counts, but cannot tell the difference between the posts, resulting in the same predicted values for all posts in the user. There has been several challenges for our project. We tried to use different types of neural networks, but it didn't work very well. Also, it was hard to find elbow point for k-means clustering. Also, for both models, prediction results were less reliable for users with less than 2,000 followers. We think a possible explanation could be for users with small number of followers, social factors are more important than the photo itself. Also, for the users with many followers, such as celebrities, photos actually play a greater role in getting attention.
In conclusion, I think we successfully predicted the number of likes that a photo can get, especially for popular accounts with huge number of followers. However, I think we should attempt to predict the number of likes for profiles that have small number of followers, and also attempt prediction via user-specific machine learning techniques. Thank you for listening, and happy Instagramming!